Supabase has made it incredibly easy for developers to manage a Postgres database, and Supabase itself is just Postgres, so we can interact with this data in any way you like. So this can be directly through Postgres' own connection string using an ORM like Prisma or Drizzle, or using Supabase's own client-side libraries like Supabase.js. So in this video, I want to show you a high-level walkthrough of the process that happens behind the scenes whenever we use Supabase's own client-side libraries, from the moment that we initiate the query all the way till we get this data back on the client, because this query actually goes through an entire process to efficiently and securely retrieve this data. And this process starts with the query builder provided by the client-side library. So first, we create a Supabase client by providing our project URL and also a public key, so we can now query data from our database. So in this case, let's say that we want to query data from the products table that we've just created. Now we only care about the items whose category is electronics, and we only want the name and price returned. So when this query is executed, the very first thing that happens is that the client library converts this into an HTTP request. So it transforms all these method calls into query parameters. So in this case, the URL consists of the project ID and also the table name, so products, and the methods are translated into specific query parameters. So we have select name and price, and the category is equal to electronics. The client now sends this request to Supabase's backend, and within the backend, it first hits the API gateway. This gateway essentially acts as a front door for all of these API requests, and it routes these requests to the right services in Supabase's backend. But it also adds some extra security features like DDoS protection. So in this case, the API gateway forwards our request to another service in Supabase's backend, namely Postgres. And Postgres is a web server in Supabase's backend that automatically creates a REST API based on our Postgres database. Now, when our request comes in, we get to the next step, because Postgres now converts this request into a valid SQL statement. So the select query parameter translates to selecting the name and price columns, and the category becomes a where clause. Now this is a valid SQL query, so theoretically we could already query our database like this. But before doing so, Postgres first turns our query into a prepared statement. So a prepared statement is essentially a reusable template for your SQL query. And this is important because let's say that Supabase were to build our SQL query like this by concatenating certain strings. Now this could lead to a SQL injection attack. So for example, if someone passed in this input, they would trick the database into returning all products and not just electronics. Of course, this is a pretty innocent example, but you can imagine what else they can do with that. So this is why Postgres uses prepared statements. So it creates this template with placeholders, and it then executes this statement separately with the actual value of electronics. And this approach not only prevents these SQL injection attacks, but it also improves the performance because Postgres can actually cache and reuse these query templates for any future requests. Now, finally, it's time to send this query to Postgres and execute this statement. But there's one thing to consider first. When you're building an app and it goes viral, it can happen that suddenly thousands of users are making database queries at the same time. And each database query typically requires a connection to the database, but creating a new connection for every request would be really slow and also take up a lot of resources. So instead, Postgres handles this through connection pooling. Instead of creating a new request each time, it already has a set of pre-established reusable connections to use. So now when a new request comes in, they can just use an already established connection to the database instead. The connection pool is configured to be the most optimal for your project, and Postgres handles all the complexities of managing these connections. So now finally, Postgres sends this prepared statement to Postgres. But there's one more step, row-level security. Before executing this query, Postgres first has to make sure that whoever sent this request is actually allowed to read this data from our database. So when we created our products table, we also had the option to apply row-level security. And row-level security is a Postgres feature that restricts database operations on a row level. So for example, we can still create a specific policy that says that only authenticated users can view our products. So this specific policy tells Postgres like, hey, when someone tries to read the products table, check if they're logged in, if they're authenticated, and if they are, then let them show the product that they want. And Supabase's own authentication system works hand in hand with row-level security. So to see this, we actually have to go back to step 2, the creation of the HTTP request. So let's say that within our app, we used Supabase Auth to authenticate users. So a user logged in, and this user initiated that request. This user's JWT is now automatically added to the HTTP request as an authorization header. So now when the request comes in, Supabase automatically makes this request either authenticated, so it has an authorization header and that's valid, or it's anonymous if they are not logged in. So now when Postgres processes our query, it automatically applies any row-level security that we've set up. And these security checks happen at the database level itself, so we don't need to modify any of the queries to include them. Finally, Postgres executes our query and returns this raw data. And as this raw data comes in, Postgres automatically transforms each row into valid JSON. After Postgres has transformed this raw data into JSON, it sends it back to the client. And the client-side library now processes this data stream into native JavaScript objects. And as it's doing so, it also checks for any errors, and eventually it makes this data available within your application. Now, finally, our Supabase query has gone through all the necessary steps to actually return this data. So the client-side library automatically takes care of the request, processing the stream JSON, converting this JSON response into JavaScript objects, and also handling any errors that might occur during our request. If there are any issues with the connection or the request, this error is made available through the error object within your application. Finally, we have the end result, from URL transformation to SQL preparation, connection pooling, JSON streaming, and so on. But the nice thing is that you don't have to think about any of this complexity. As developers, we just have to write a simple declarative query, and Supabase takes care of everything else. And that's the power of Supabase. It handles all this complex infrastructure behind the scenes, so we can just stay focused on creating the best applications.